Hello everyone. Today let's solve the Leetcode problem number 153. Find minimum in rotated sorted array. Suppose what the question says. Suppose an array of length n sorted in ascending order rotated between 1 and n times. For example, the array nums 0, 1, 2, 3, 4, 5, 6, 7 is there. It has been rotated 4 times. Nothing but 4, 5, 6, 7. This will be at the beginning of the array, right? That's what they have given here. 4, 5, 6, 7, 0, 1, 2. It was rotated 4 times. If it was rotated 7 times, then it would be 0, 1, 2, 3, 4, 5, 6, 7 again, right? So, also, given the rotated sorted array of unique elements, return the minimum element of the array. They have strictly mentioned return the minimum element of the array. And also, you must write an algorithm that runs in big of n log n time. So, log n time, sorry. So, we have to write the code that runs in big of log n time. So they have strictly mentioned we have to write the code in that runs in big of log n time, right? Suppose let's take this example. We have the array of numbers 3, 4, 5, 1, 2, and the output we got is 1 because the lowest number that is found is 1. So basically what we can do here is we can just sort the numbers and sort the numbers in the ascending order and return the first element, right? So, but the time complexity, if we sort, the time complexity would become big of n log n. And they have strictly mentioned in the question that we have to write the code that runs in big of log n time. So, what we can do, we can find the minimum element using the binary search. Let's see how we can do that. So, I'll just come here. Let me consider this example and show you. So, we have the array of numbers 3, 4, 5, 1 and finally 2, right? So, what we'll do initially, so first let's check, let's find the middle element. So, here in this case we have the middle element 5. So, we'll check whether the middle element is greater than the rightmost element or not. This one, rightmost element. If the middle element is the rightmost element, this one, the least element will be mid plus 1, nothing but this one. So, the least, the minimum. So, the minimum in the rotated sorted array would be 1, right? So, in this case, that's what we have got, right? So, in this example also, you can see we have 4, 5, 7. In this case, this one is the middle element and we will check whether this is greater than middle element or rightmost element or not. If it is greater than, the mid is greater than the rightmost element, we are displaying the next element to the mid, nothing but this one, 0. Yeah, we have got the output 0. But in the third example, we can see this one is the mid element and we will compare the mid element with the rightmost element, nothing but 17. We will check whether 13 is greater than 17. 13 is not greater than 17, right? Then we will display the leftmost element to the mid as this one, minimum number, nothing but 11, right? So this one, that's what we will be doing here. So I'll just delete this one. Let's start writing the code. So initially what I'll do, just give me a second. So first what we'll do, let's initialize the left pointer L to the start of the array as well as the right pointer R to the end of the array. How can we do that? I'll just give let L equals 0 and let R equals length of the nums minus 1, nothing but the last element. We are assigning the L to the first index and we are assigning the R to the last index. Next, let's perform the binary search, right? Until left pointer is less than the right pointer. So, I'll just make use of the while loop for this and just give left less than right. L is nothing but the left and R is nothing but the right. These are left pointer and the right pointers, right? So next, let's calculate the middle index M using the bitwise right shift for floor division by 2. How can we do that? In simple terms, we are calculating the middle element. How can we do that? Let mid equals, for mid I'll just consider the variable name m, and let me make use of the matplotlib, or I'll just go with the tilde operator. And just give left plus right by 2. We will get the middle element. Then after finding the middle element, if the middle element is greater than the rightmost element, then we will display the minimum must be in the right half, right? So for that one, I'll just give, I had explained with the example by taking the examples, right? I'll just make use of if condition, if nums of m greater than nums of r, then left is equal to mid plus 1. As I've showed you, else we will assign right equals mid. Next, we will return the minimum element found at index L finally. For that one, I'll just return nums of L. So let me format this code. Let me hit the submit. So yeah, just give me a second. So what is wrong? Mid is not defined. Line number 7. So in this case, I have considered the variable name m, right? Sorry. So I'll just format this one again and hit the submit. So yeah, now you can see this is working correctly, right? So what's the time complexity and the space complexity of this one? The time complexity would be log n. Why? We are making use of the binary search. First thing, the while loop performs the binary search. This one, the while loop performs the binary search, reducing the search space by half of each iteration, right? So the time complexity would be big O of log n, and the space complexity here is we are making use of the constant amount of space regardless of the input size. Nothing but the space complexity is big O of 1. So here I'll come, the time complexity would be big O of n, and the space complexity would be big O of 1. So this is it. Thanks for watching, guys.